Have you ever wondered how Netflix knows what movie to recommend next, or how Siri can understand your commands? The answer lies in two words: machine learning and deep learning. These two buzzwords have been making waves in the tech world and beyond. But what do they really mean? Simply put, machine learning and deep learning are subfields of artificial intelligence. They're the secret sauce behind many of the technologies we use daily, from voice assistants to self-driving cars. Machine learning involves computers learning from data to improve their performance, while deep learning goes a step further, mimicking the human brain to process data and create patterns for decision-making. These technologies are not just transforming our lives, but are also catalyzing the next industrial revolution. So buckle up as we delve into the fascinating world of machine learning and deep learning. Machine learning is not just a single technique, but rather a collection of methods, each with its own strengths and weaknesses. Just as a toolbox contains a variety of tools, each designed for a specific task, machine learning is a toolbox of methods, each tailored to solve different types of problems. The first layer we'll peel back is supervised learning. This is the most common type of machine learning, where we teach the machine to learn from labeled data. Think of it like teaching a child to identify fruits. We show them an apple and say, "This is an apple." We do the same for other fruits, and eventually the child learns to identify them on their own. Similarly, in supervised learning, we provide the machine with inputs and the corresponding outputs. Over time, the machine learns the relationship between the two and can predict the output for a new input. Next, we have unsupervised learning. Imagine a child playing with a box of assorted toys. Without any guidance, they may start grouping the toys based on their shape, color, or size. This is the essence of unsupervised learning. We give the machine a bunch of data and let it find patterns or groupings on its own. This method is commonly used for clustering and anomaly detection, like identifying unusual credit card transactions. Lastly, we have reinforcement learning. It's like teaching a dog a new trick. You don't explicitly tell the dog what to do. Instead, you reward it when it does something right, and over time, the dog learns the trick. Similarly, in reinforcement learning, the machine learns to make decisions by interacting with an environment and receiving rewards or penalties based on its actions. It's used in various fields, including robotics and gaming. Each type of machine learning has its own unique approach, making it suitable for different types of problems. So there you have it, the three primary layers of machine learning, each with a unique way of learning from data and solving problems. Now, aren't you curious to dive deeper? Deep learning, on the other hand, is a subset of machine learning. It might sound complicated, but it's actually quite simple. Deep learning is a machine learning technique that teaches computers to do what comes naturally to humans: learn by example. It's all about artificial neural networks inspired by the human brain. These networks draw from vast amounts of data, learning to identify patterns and make decisions. Now, let's tackle the different types of neural networks. Picture a web, a network of interconnected layers where each layer represents a level of understanding. These layers are like the building blocks of knowledge, and the connections between them are like the pathways of learning. One of the most common types of neural networks is the convolutional neural network, often abbreviated as CNN. These are primarily used for image processing, pattern recognition, and computer vision tasks. If you've ever used a photo filter or facial recognition software, you've likely interacted with a CNN. These networks scan an image from left to right, top to bottom, identifying different features and patterns. Another type is the recurrent neural network, or RNN. These networks are used for sequential data, such as time series analysis, speech recognition, and language translation. They are unique because they have a memory function. They can remember previous inputs in their hidden layers, allowing them to understand context and make predictions. Deep learning, with its various types of neural networks, has a wide array of applications. From self-driving cars that can identify pedestrians and other vehicles to voice assistants that can understand and respond to your commands, the uses are vast. But remember, the power of deep learning comes from the data it's trained on. The more diverse and extensive the data, the more accurately these networks can learn and predict. This is why data is often referred to as the fuel for deep learning. You see, deep learning isn't just about algorithms and networks. It's about harnessing the power of data to understand the world around us, to solve complex problems, and to create innovative solutions. Deep learning, with its ability to learn from vast amounts of data, is at the forefront of many technological advancements. Now that we've explored machine learning and deep learning, you might be wondering, what's the difference? Let's start with their data dependencies. Machine learning algorithms can work with relatively small data sets. They can learn and produce reliable results from hundreds or thousands of examples. On the other hand, deep learning requires massive amounts of data to function effectively. We're talking about millions or even billions of examples. The more data you feed into a deep learning system, the better it performs. Next, let's talk about computational complexities. Machine learning models are less computationally intensive. They can run on common hardware without the need for specialized processors. Deep learning, however, is a different beast. It demands powerful hardware, often requiring high-end GPUs and sometimes even dedicated servers. The reason is the complex neural networks that deep learning employs, which need a lot of processing power to learn from the vast amounts of data they consume. Finally, consider their problem-solving capabilities. Machine learning is fantastic for tasks where the solution can be defined by a clear set of rules or features. Think spam filtering or credit fraud detection. Deep learning shines when the solution isn't clear-cut. It excels at learning from unstructured data like images or natural language. It's the technology behind voice assistants, understanding your commands, and self-driving cars recognizing objects on the road. But it's not a competition. Machine learning and deep learning are not mutually exclusive. Rather, they're tools in the same toolbox. Machine learning can provide quick and efficient solutions for simpler problems, while deep learning can tackle more complex tasks that require understanding of unstructured data. And in some cases, they even work together, with machine learning algorithms feeding into deep learning systems to provide a more comprehensive solution. While both machine learning and deep learning have their own strengths, they complement each other in many ways. So, why should we care about machine learning and deep learning? Well, let's take a look around. The influence of these technologies is pervasive, subtly weaving into the fabric of our everyday lives. Let's explore a few sectors where they've made a significant impact. In healthcare, machine learning and deep learning are revolutionizing the way we diagnose and treat diseases. Algorithms can now analyze medical images with incredible accuracy, often matching or even surpassing the capabilities of seasoned professionals. They're also helping to predict health risks and personalize treatment plans, potentially saving countless lives. Next, let's talk entertainment. Ever wondered how Netflix seems to know exactly what you want to watch next? That's machine learning at work. By analyzing your viewing habits and preferences, it can recommend shows and movies that you're likely to enjoy. And it's not just Netflix. From Spotify's music recommendations to the personalized news feeds on your social media, machine learning and deep learning are shaping your entertainment experience. Now let's shift gears and talk about transportation. Self-driving cars are no longer just a sci-fi fantasy. They're here, navigating our roads and highways thanks to machine learning and deep learning. These technologies are the driving force behind these vehicles, enabling them to recognize traffic signs, avoid obstacles, and make split-second decisions. And this is just the tip of the iceberg. These technologies are also transforming sectors like finance, retail, and even agriculture, making them more efficient and effective. They are helping us predict stock market trends, personalize shopping experiences, and optimize crop yields, among many other things. So as you can see, machine learning and deep learning are not just high-tech jargon. They're instrumental in shaping our future, driving progress in virtually every sector. They're helping us make sense of vast amounts of data, automate complex tasks, and make predictions that were once beyond our reach. Indeed, machine learning and deep learning are not just buzzwords. They are powerful tools that are transforming our lives in unimaginable ways. In today's digital age, machine learning and deep learning are more than just fancy jargon. They're the hidden gears turning behind the scenes, making our day-to-day lives more streamlined and efficient. We've peeled back the layers of machine learning, from simple algorithms to complex neural networks. We've dived deep into the realm of deep learning, exploring how it mimics the human brain to process data and create patterns. We've compared and contrasted these two technological titans, highlighting their unique strengths and applications, and we've seen the significant impact they have on our world, from enhancing business operations to driving groundbreaking research. These technologies are not just transforming our present, they're shaping our future. They're the tools we'll use to solve problems we can't even imagine yet. As we continue to explore these technologies, who knows what amazing things we'll discover next? Stay curious, stay informed, and remember, the future is now.